Alrighty, section 4.0, we'll be seeing that a lot. This is theorem 4.0.4, and its determinant of A is equal to the determinant of A transpose. And they say this is a induction on N. They don't give us a proof. We'll sketch out what's going on, all right, and why it's an induction on N. Really, you use theorem 4.0.3, and that is that I can expand by any row or any column. Okay, so if I want to do the determinant of A, right, I could expand by, so if I'm doing A, I can use the first row, and as I grab that one, then I would look at the minor of this matrix here. I'd get that determinant for this submatrix here. Well, if I'm looking at A transpose, then all of a sudden, right, I'll expand that by the first column, and then so I have that element. Well, they're exactly the same element. But now, when I think of this minor, well, these columns here became these rows here, and so I would need that. Even though they're the same, it is the transpose. So this is, some. I'm going to call it A11 as that submatrix of deleting the first row and first column. Well, this one is A11 transpose. And so what you are doing is, in the definition of the determinant, we're going to expand by this first column, first row for A, expand by this first column for A transpose. But where the induction hypothesis comes in is that, here I'll use, well, I've got my -1 to the, in this case, 1 plus 1, and then I need the A11, and similarly over here I'll have -1 to the 1 plus 1, I'll need A11, so that's all great. But then I need to multiply by that determinant of our submatrix here. And so rather than write it as the minor, I'm going to write it as the determinant of A11, and here I'm going to write it as the determinant of A11 transpose. And so you see that as long as the induction hypothesis is going, those two things will be equal, so that first term of my summation will be equal. And then, I go to the next one, and that's just all we'll really need to look at here, I think. So I go here, and I'll need to toss that one in. But that's, the same thing as here, and so I'll need this submatrix and the minor that goes with that. But once again, you see, if I call this A21, the submatrix here of these rows and columns, then that is the same matrix as A transpose 1, 2. So those are the same matrices. So when I do here, -1 to the 1 plus 2, and then A12, determinant of A21, here I'm going to use -1 and 2 plus 1, and then A2 1, and then the determinant of A transpose 1 2. But see, again, the induction hypothesis says, oh, those two determinants are going to be the same, and of course everything else evaluates to the same because, oh, I forgot my little transpose on that, and I should probably put a little transpose on that. So this is A21 from the transpose, but that is exactly the same as A12 in the original matrix, and so we go through the summation of n like that, and we're using the induction hypothesis there. Okay, so that is how that proof works, and we get the determinant of A transpose is equal to the determinant of A. Okay, so there is that theorem.